Let's have the second set of word problems which can be solved by system of linear equations. Okay, these are the digit problems. Let us have example number 1. The sum of a two-digit number is 13. Each unit digit is 3 less than its tens digit. Find the two-digit number. Okay, we are going to represent the tens digit with x and the units digit with y. Okay, going back to the condition in the problem, the sum of a two-digit number is 13. So since x is represented by, the tens digit is represented by x, and the units digit is represented by y. So our equation 1 should be x plus y is equal to 13 as given in the problem. So we have equation 1. Okay, for our equation 2, let us go back to the second condition. Each units digit. Okay, what is the units digit? The units digit is y. Okay, I told you that the word is means equal. So the units digit equals 3 less than its tens digit. The phrase less than should be subtraction. Same as with more than, less than should be, if ever the phrase less than is used in the problem, the first term mentioned here in the phrase should be written as the last, and the tens digit represented by y should be written as the, represented by tens digit, should be x, should be written as the first. Okay? So that our equation 2 should be y is equal to x minus 3. Okay? Were you able to follow in forming the two equations that form the system of linear equations? Okay, let's have now the solution. Step 1, you have to write the equation 2 in standard form. Okay, but we can have it this way, remain it this way. But it's up to you whether you write in standard form or not. If the equation 2 will remain as is, you do the substitution method. But I will use step 2, the elimination method. That is why I have equation 2 to be written in standard form. So step 2, the elimination method, I have now both x terms to be cancelled because both terms of the x's are the same, but the signs are different, are opposites. So let us now have the y terms and the constants. Y plus y, we have 2y. 13 minus 3 is positive 10. Divided by 2 for both terms, so that y is equal to 5. And 5 will be our UD, or the units digit. To find the tens digit represented by the x, we substitute y equals 5 in equation 1. So this is now our equation 1. X plus y equals 13. The substitute, the y. So x plus 5 equals 13. Transpose 5 with 13. So x equals 13 minus 5. Therefore, x is equal to 8. 8 is the tens digit, or the TD. So therefore, if you're going to combine now the UD and the TD, be sure you write first the TD before the UD. So the TD is the tens digit, the UD is the units digit, therefore the two-digit number is 85. So let's do the checking. Using equation 1, substitute the values that we got. For x is 8, for y is 5, add 13 equals 13. So 13 is correct with 13. What about the equation 2? Substitute the values. For y we have 5, for x we have 8. 8 minus 3 is 5. 5 is equal to 5. Check. So that means the values we got for x and y are the correct values. Okay? Okay. Time for copying. Okay? Number 2, digit problem. Find the 2-digit original number if its units digit is thrice the tens digit. If the digits are reversed, the new number is 10 more than twice the original number. Okay? So we're asked to find the 2-digit original number. For the representation, let's have x equals the tens digit and y equals the units digit. Remember, our number has place value. Okay, to form the number, we have to have the place value. Since here x is equal to the tens digit and the place value of x is 10 plus y, the place value of the units digit is 1 once. So we have here 1, or no need to write 1 here. It's understood. 1 times y is y. So this is the representation of the original number. Since the new number is part of the problem, we have to represent the new number. So the new number is, it is said in the problem that the new number is formed when the digits are reversed, meaning this will become the tens digit and this will become the units digit. So that in our representation for the new number, y now is the digit, y term is the digit for the tens and x is the digit for the ones. So this is the representation of the new number. Okay? Do you get me? Okay, that's good. For our equations, okay, we will go back to the problem to form equation 1. It is mentioned in equation 1 that if the condition, if its units digit is thrice the tens digit. What is the units digit? The units digit is y, is, which is equal sign, thrice the tens digit. So that our equation is y equals 3x. Now, this is our equation 1. For our equation 2, we have to consider the second condition. It says, if the digits are reversed, okay, so the x will become the units digit, the y will become the tens digit, as represented here in our new number. Are reversed, the new number is 10 more than twice the original number. So we have to write first the new number. What is the representation of the new number? 10y plus x, 10y plus x is here, is 10 more than, okay, the word more than, 10 more than twice the original number. Again, the second condition says the new number, as represented here, is 10 more than twice the original number. So it's quite long. Equation 2 is quite long. So for solution, step 1, we have to simplify equation 2. Okay? So equation 2 is copied, then simplify. 10y plus x equals 2 times 10x is 20x, 2 times y is 2y plus 10. Combine I combine the y terms because in equation 1, the y is at the left term. So that is the reason why I have to put it that way for the second equation. Then 20x, transpose the x term to the right so that x will become negative from being positive at the left side. Constant is 10, so plus 10. Then 10y minus 2y is 8y equals 20x minus x is 90x plus 10. This will now be our equation 3. Step 2. Substitute equation 1 in equation 3. Equation 1 means the value of y is 3x. This is equation 3. Instead of writing y, I wrote the value of y as 3x as given in equation 1 equals 19x plus 10. Multiply 8 times 3x is 24x equals 19x plus 10. Okay, continue the solution. So we have to move 19x with the 24x to the left equals 10. 24x minus 19x is 5x equals 10. Divide both terms by 5 so that x is equal to 2 and the value of x, now 2, is the TD or the tens digit. For step number 3, substitute x equals 2 in equation 1. So equation 1 is y equals 3x, y equals 3, the value of x is 2. I'll just rewrite. So the 3 times 2 is equal to 6. It's our UD. If 6 is our UD and 2 is our TD, the 2-digit number formed as the original number is 26. Okay? Checking y equals 3x, equation 1, 6 for the y, 3 times 2, 6 times is equal to 6. The second equation transform, now label it equation 3. So we have 8y equals 19x plus 10. For the value of y that we got is 6, for the value of x is 2, therefore 8 times 6 is 48 equals 19 times 2 plus 10. So 48 equals 38 plus 10. 48 is equal to 48. Check. Do you understand? Okay. Copying time. Try to solve the problem, the digit problem that I have here. Just follow this, understand the problem, see to it that your representation is correct, and so the two equations that will be formed, then show step by step that will compose the solution. Do not forget to write the correct label for your answer. Okay? Good luck.